Hi, in this video we're going to start the material on bonds. As I mentioned before, the bonds are nothing more than loans, and so you'll see we're going to use a lot of the same notation or all of the same notation as with loans, but the terminology is going to be a little bit different. Just to kind of get set up a little bit, most people think of bonds, they think of this as a type of investment, and there's the two main types of bonds are municipal bonds, which are government bonds, and corporate bonds. And I tend to think more along the lines of corporate bonds when I'm thinking of a bond. I'm in that context of maybe buying a corporate bond. And so the reason a company might issue a bond, and that's what they call it, is issuing a bond, is when they need some money to maybe develop a new product, and so they have options to get the funding to develop a new product, and one of those options is to issue bonds. And when they issue bonds, that allows us, people like us as investors, to buy those bonds. So if we wanted to invest in a company, we could invest in the company by buying their stock. When we buy their stock, it's called equity. We're buying equity in the company because we're becoming part owner of the company. The stockholders are the owners of the company. So when we buy stock, we buy ownership in the company. Whereas when we buy a bond, we're actually buying the company's debt. The company is actually we're lending our money to the company. The company is taking out a loan from us. So they're the borrower and we're the lender. Okay, I'll get into that in more details later on. Okay, so let's go ahead and get started. As I mentioned before, the notation is going to be the same, but the terminology will be a little bit different. So let's look at an example. This is a typical example of all the types of words that you're going to see in a bond problem. You buy a 10-year 1,000 face value bond with 8% semi-annual coupons and a redemption value of $1,200. The price of the bond is $1,259.51 to yield 6% compounded semi-annually. So let's pluck out some information here. The price of the bond, I'm going to use a cap P to represent the price of that bond, and that's what we're going to pay today. So we're going to buy this bond, we're going to pay this today. That's what we're lending. We're lending that money to the company. And whenever you buy a bond, you buy it to yield a certain interest rate. We're buying this bond to yield us a semi-annual effective interest rate of 3%. The yield rate will always be the I value that I'm going to be using throughout the rest of the videos. The I value is a periodic effective interest rate always. Unless you're told otherwise, it's assuming it's a periodic effective interest rate. The way it's worded in the problem is they gave me a nominal rate of 6% compounded semi-annually. I recognize that's equivalent to the 3% semi-annual effective interest rate, so that's the yield rate. And then they have this redemption value. In that first sentence at the end, it says the redemption value is $1,200. I'll use a cap R to represent the redemption value, and it's always paid at the end of the term on the bond, or when the bond matures. They'll say when the bond matures. In this case, the bond matures in 10 years. It's a 10-year bond, and so that's when the redemption value is paid. Notice that magnitude-wise, the redemption value and the price are pretty close in the same, magnitude-wise, are pretty close to each other. So you can think of, not exactly, but you can kind of think of the redemption values paying you back your money, paying you back whatever you paid them. I'll come back to that again in just a second. So far, this is the notation that we have. We have this price. We have the cap P is the price, I is the yield rate, and cap R is the redemption value. The next two things, next two notational symbols I'm going to put together in one at the same time. It's the face value, cap F, and the coupon rate, R. The face value, another word for face value might be par value. So if you see the word par value, it's again the same as face value, and we denote that by cap F. The coupon rate we denote by an R. It's also a periodic effective interest rate, just as the yield rate is a periodic effective interest rate. I put those two, the cap F and the cap F and the R, together because when you multiply those two things together, you get what's called the coupon payment. So cap C, I'm denoting as the coupon payment, and I get that by multiplying by multiplying the face value times the coupon rate. So let's go back to our example. At this point, we've already talked about the cap P, the I, and the cap R values. Now the face value, it's very easy to pluck that number out of the problem. Face value is 1,000. It tells me, and again, it might say par value there, but that is represented with a capital F. And the R value, the coupon rate. Now be careful, you see that 8%. It's 8% semi-annual coupons. The 8%, the whatever is quoted there, is always a nominal annual rate, and then it's payable, in this case, semi-annually. So I got to take that nominal rate of 8% divided by 2 to get the coupon rate as a semi-annual effective interest rate of 4%. Going back to that coupon rate of, well, let me mention then, multiply the cap F times R and you get 40. That's what the coupon payments would be. And the coupon payments, it says it's got semi-annual coupons for 10 years, so the coupons are paid every 6 months for 10 years. So going back to that 8% rate, again, it's a common mistake that students will say, oh, the coupons are going to be 80. 8% of 1,000 is 80. That's 80 on an annual basis, but it says that they're semi-annual coupons. So on an annual basis, you're getting $80 per year, but you're getting that in 2 equal semi-annual coupons of 40 each time. So that's why the R value there is 0.08 divided by 2. It's a semi-annual effective coupon rate. Okay, so we can capture all this information now in a timeline. We pay a price $1,259.51 at time, when we buy the bond, and then at time 20, you see that $1,200 on top, on the top red at time 20. That's the redemption value that we're going to get at time 20, which is 20 semi-annual periods from now, 10 years. That's 10 years from now. And notice the coupons are paid every 6 months for those 10 years. That's why I have 20 as the last time value. And so the coupons, so in exchange for us lending our money, we're paying $1,259.51 to this company. In exchange, we're going to get 40 at the end of each month. At the end of each 6 months for 10 years, and then at the time of that last payment of 40, we're going to get that $1,200. So those 40s can be thought of in a way, not exactly, we'll get into the details later, but the 40s can be thought of as maybe paying interest along the way, and then we get the $1,200, that big chunk, the redemption value, because it's magnitude-wise on the same level as the price. We can kind of think of that as getting our money back, and the 40s, the payments of 40 along the way are paying us our interest along the way. Not exactly right. We'll get into the details later of that. Okay, going back to some more notation and terminology, just like with loans, we have this notation cap I with bonds because loans and bonds are the same thing. Cap I is the amount of interest earned with the kth coupon. Now that's a little bit different than the wording on what cap I is with loans. If you look at a loan, the interest on a loan we pay. And so cap I sub k in the context of loans would be the amount of interest paid with the kth coupon. Here it's the amount of interest earned with the kth coupon because we're earning interest because we're the lender now. So we're earning interest on what we paid on the amount that we paid on the bond. So cap I sub k is the amount of interest earned with the kth coupon. We also have the symbol cap P sub k in the context of bonds. In the context of loans, cap P sub k is the amount of principal repaid, but in the context of loans, we say that it's the amount of principal adjustment. We'll get into the details, into the weeds on these cap I's and cap P's in another video, but for right now, that's just symbolically what the cap I and cap P are representing in this case. And of course, just like with loans, the total payment is equal to the sum of the cap I and the cap P. This time the total payment is called the coupon payment, so cap C is equal to cap I sub k plus cap P sub k. And then finally we have balances. We talked about balances with loans, we don't call them balances on bonds. We call it a book value. So cap B sub K is going to be the book value, and another word for that is amortized value, but you're more often going to see the word book value immediately after the kth coupon. So here's our timeline again, and if we look at some time K between time 0 and when the bond matures, we have a book value just after that kth coupon. This is all just like before with loans. We can look at the book value at time 0, and that would just be the price of the loan, similar to how the book value, similar to how the balance at time 0 is just the loan amount. So the book value at time 0 is the price that we're paying. That's it, you can think of that as the loan amount. That's how much we're lending. The price that we pay is what we're lending the company. And then at time N, we're going to have a book value at time N. Now, the balance at time N on a loan is always 0, but the book value at time N on a bond is always the redemption value. So be careful with that. So the way to think about this is, in parentheses, I have it listed here, is that the last coupon at time N, we think of that last coupon as being paid just before time N, maybe 1 second before time N. So that's at time N minus. And then the redemption value being paid at time N plus. And so remember, the book value, we can think of the book value at time N prospectively as the present value of the future payments. Well, at time N, because the last coupon was paid just before time N, that was a past payment, but the redemption value is paid just immediately after time N, so that is a future payment. So the book value at time N, being the present value of the future payments, would be equal to this cap R, the redemption value, if we think of it this way, which we're going to think of it this way. Okay, so moving the valuation date to, say, time K, I've got this book value just after the kth coupon. And before, with loans and balances, I'll also want to be sometimes interested in calculating the book value just before the kth coupon payment. So I'll denote that with a cap B sub K before. And remember this relationship, same relationship that we have with loans. It's just we don't say balances anymore. With bonds, we say book values. So if you take the book value before the before the payment, subtract off the payment, you'll get the book value after the payment. And then you can add the cap C to both sides and you'll get this equation. And then finally, there was one other way to think about the book value at time K versus before and after. If we back up to time K minus 1, there's a book value just after the K minus first coupon payment. And then we would need to accumulate that with interest by multiplying by 1 plus I to get the book value just before the kth coupon payment. So these were the two ways to get book values before the kth payment. And again, they're exactly the same as balances in the context of loans. Finally, there's one last thing that I want to comment on, and that has to do with some things that we've discussed already. This is our timeline, our general timeline for a coupon bond. I'll call it a coupon bond, meaning that this is a bond that pays coupons. We have this idea of a zero coupon bond. A zero coupon bond is just exactly what it says. The coupons are zero. And if the coupon payments are equal to zero, then we don't need to put them there. And so our timeline would not have any coupons. We just have a redemption value that's going to be paid. So this is the picture of a zero coupon bond. These are going to show up quite a bit in the next module, in Module 4. Zero coupon bonds show up quite a bit. And also we've actually already talked about them a little bit in Module 1, because we talked about T-bills, what were called T-bills, and those were municipal bonds, government bonds. A T-bill was a bond that had a very short duration, like an 80-day or a 90-day T-bill or a 180-day T-bill. Those are bonds that mature in very short periods of time, 90 days or 180 days and so forth. So those T-bills are government bonds that mature in less than 1 year. That's technically what a T-bill is. And we talked about those T-bills because the way that we compared the price and the redemption value with T-bills was by using, with T-bills, I'm talking about specifically with T-bills, was to use simple interest or simple discount, depending on whether you had a Canadian T-bill or a a US T-bill. But the zero coupon bonds are also going to show up in the next module, module 4, and we're going to price those zero coupon bonds based on a yield rate, which is, again, a periodic effective interest rate. So we'll be using V notation in Module 4 when we price zero coupon bonds. Anyway, I just wanted to bring that up quickly. That's going to show up in Module 4. But for now, we're going to focus on coupon bonds, and we're going to really, in the next few examples, look at the details involving the amount of interest earned each period and the amount of principal adjustment during each period. Okay, so I'll see you in the next video.